Check, check. Oh my gosh. Hey, can you guys finally hear me? Desktop audio 2. Let's see. There we go. Okay. Sorry, guys. One of the things that happens with this whole live streaming deal is there's a moderately complex piece of software that goes with it. It's OBS Studio. Fortunately, it's free, so yay, free. But at the same time, it's just something that I use so infrequently that it can be difficult to to make sure everything's working properly. So looks like we got a few guys on here. Tom and Jeff from eMasterCam. So do you guys have clear video or is it funny? No, let me see what's going on here. I don't think it's you, man. I think it's let's see, left monitor. Let's go properties and cursor capture method, automatic. I don't want like a scene transition, so turn that off. I don't want to swap out this thing after transitioning. Let's see, what are we getting here? Name of video, stream latency. Stream is healthy. There you go, you got it. Yes, it's all good. Okay, is it? Looks good to me. Okay, so hopefully the stream quality is there. I guess, always, you can text me, alert me in the text box, and I'll try as I'm talking to not do like a lot of motion, because I think if we do like a lot of quick motion, that can sometimes lead to the stream going blurry. I know also, oh good, your quality settings were set low for some reason, so at least you got that bumped up. That's great. By the way, my Microsoft LifeCam webcam's kind of piece of junk. Just so throwing it out there. If it freezes, hopefully it'll come back. If not, sometimes I have to go into the OBS software and switch over to my laptop real quick. Switch basically video sources and then switch back. So I got asked by one of the members on eMasterCam, Jeff, to take a look at this particularly large file in Mastercam and talk about some options for dealing with large data files. So how do we deal with Mastercam files that start to get really big? First of all, why do they get big? What's going on? How do we deal with increasingly large data sets in a Mastercam file? That's when all you're doing is dealing with like a single part and kind of moderate complexity, it's not so bad. But when you start kind of getting above, I would say about kind of the 100 megabyte mark, things start to get bogged down. So once we're taking multiple solid models, surface models, kind of laying them over the top of each other, and then taking all this data and rotating it through 3D space, the calculations, start to not necessarily bog down our graphics card specifically, but it also starts to bog down the pipeline of taking data that's stored in memory and moving it to the processor processing that data and then moving it back and storing it. So you got all these things moving around through a pipeline, and data being stored and then data being moved into the processor, manipulated, worked on, and then it goes back. So one of the things that can be a real advantage to you is to look at not only you got to look at everything as a package. So ideally what you're going to have is a combination of a fast single core processor. So, and I'm not talking necessarily about only having a single core processor, but the most important thing for a Mastercam computer is a fast clock speed. So don't be fooled by the chips that are being sold for doing multi-core processing, because you can get an 8 or 16 or a 32 core processor that works great if you're doing rendering. It works great if your software is built to take advantage of a true multi-core processing model. But for Mastercam, what you really want is a fast clock speed. Let's see. So one of the things that you guys will see, or that I've seen over time, Mastercam is the Swiss Army knife of CAM softwares. And I say that with much love and much respect, that there are a lot of technologies under the hood that are licensed from other developers. And they have done a decent job of creating a front end that brings together a lot of different technologies, right? And it integrates them together into a CAM package and kind of gives you a lot of different tools and a lot of different ways to attack a problem. But you're right in some ways that the back end is not necessarily modern, and things that should in other software packages be easy to accomplish really start to become taxing in a software that is made up of a lot of different components that were bought from other people, or licensed technically, I guess, from other people. So we have to start doing a little bit of work to manage that data and making sure that we're getting the most out of our systems. So for example, I'm going to go to File, I'm going to go down to Configuration, and we're going to look at a couple of things. First thing is under Toolpaths. The default memory buffering here is 50%. So kind of by default, Mastercam is set up to only use half of the available RAM. And honestly, what you'll see in a lot of cases for toolpath calculation, RAM is not the problem. I mean, you may have 64 gigabytes of RAM, you may only be using 4 gigabytes or 6 or 10 gigabytes of RAM, so you're not even approaching that theoretical 50% limit, but it still takes a while to do a toolpath calculation. So again, the fastest single core processor speed that you can get, the better. So if it has 4 or 8 or 16 cores, that's great, but what you want is a 4 or 5 gigahertz default clock speed, not with turbo boost enabled or any of that other stuff. The fastest i5, i7, i9 chip you can get. The other thing that will affect this is cache, C-A-C-H-E. If you're in Britain, that may be cache. I think they pronounce it a little differently. But you can think of the cache as kind of like preparatory memory. And it's like pre-processing memory and post-processing memory. So data comes in on the pipeline, it gets kind of distributed in this cache to get it ready to go through a clock cycle on the processor. The processor then performs its calculations, and then puts data back out, and then that data goes from the cache to back to the RAM. And that's a real simplified, high-level overview of what it does. But in general, you want the fastest processor speed with the most cache available. You also want to look at the specs that are for the processor, because not all specifications are really showing you apples to apples. So for example, there's typically 3 levels of cache, L1, L2, L3. I'm honestly not all that up on exactly what the differences are between them, but a lot of times in the processor spec, they'll give you either the level of L2 or the level of L3 cache, and you should just make sure that if you compare, say, 6 different chips, that you're kind of balancing the amount of cache that's available there. So, the most total cache memory, but sometimes, the L1 will be a little light, the L3 will be a little light, and they'll have a lot of L2 level cache, and some of that has to go with chip design. What did the designer of the chip intend the instructions to process? What is it designed to process most speedily? Yeah, smallest to largest, fastest to largest, cache levels are a hierarchy. So what we're talking about is internally in the computer, how is the chip constructed? What are the instruction sets for the chip? So how does it go about processing that data? And we're living in a time where Windows is built, I guess, with it's like a JIT instruction set. It's a just in time. And part of what's happening is we have this abstraction in software today where the interface and the data storage and how the software and database work is not designed for a specific type and set of hardware. So it's not like in the old days where you had to have a specific workstation that was configured a specific way to run to run this. We're living in a day now where the software is built to function a certain way, and then they have modules that work to convert what you want to do in the software into assembly code, and then down to instructions that can be fed into the processor, and then data results that you can get back out, and then that gets translated back into results that are meaningful for the program that's just asked the processor to do something, and it's now consuming the results of that calculation. Hey, looks like we got somebody chiming in from Mexico. Bienvenidos. Welcome. I know very little Spanish, and I'll try not to embarrass myself by speaking too much of it, but hola, bienvenidos to everyone around the world if you're chiming in. So, focus of this really is on dealing with large part files and talking about some of the concerns and pitfalls that you're going to run into when you're dealing with large data sets and large models, and how do we work with large models, and what are some of the tools that we can use to make our lives easier. So first thing, definitely on the memory buffering side. So if you go to the file menu and you go down to system configuration is where all of the settings that kind of are the default values and that drive your system configuration. So how is your system configured to work? One of the things I definitely recommend, depending on how much RAM you have available, I would bump this up to between 80 and 95%. You generally want to leave at least at least 6 gigabytes of RAM for Windows to run normally. So in this case, I've got a 64 gig computer, and you'll notice I've got my memory buffering set to 90%, so it's allowing it to consume up to 58 gigabytes, 58.8 gigabytes of physical memory. Generally, unless we're computing, something super complex with a single toolpath, I wouldn't expect it to use anywhere near that. But just in case, I do like increasing this buffering. There's got a question, shakeout with Intel versus AMD, but I'm leaning towards AMD. So I would definitely recommend you check out emastercam.com. And just pull this up real quick. If anyone hasn't been there, who might be chiming in on the stream, this actually, the reason I'm doing this today is because one of the members of eMasterCam was asking me some questions, and I figured might as well just do a YouTube live video on this, see if we can kind of help spread that knowledge around to more than just one-on-one instruction. I genuinely like teaching, no matter if it's 1 or 10 or 1,000, but I do love the reach that YouTube allows me to get. So the one thing I would definitely encourage in terms of looking at architecture, go ahead and sign in real quick. Mastercam take advantage of accelerated instruction sets. So what I would say to that is most of the commands that they're using to deal with memory are going to be I don't want to say archaic. What I want to say is they're going to make sure that the new tools and the old tools don't come into conflict. So the chances are it depends on which path you're using. So, and we'll get a little bit more on the paths in a second. So if you do go to eMasterCam and you go to this industrial forum here, there has been see if we can go to the important topics, computer benchmark thread. I know there's a benchmark 3. So let's see. I think they used to be pinned up at the top. Yeah, benchmark 3.0. So this is a continuation of a thread that's been running for a long time, where what they do is you take your PC, whether it's assembled by yourself or built by somebody else, and you kind of list the specs of everything. And you take this benchmark file and you do a specific set of modifications to the toolpath, and then you regenerate the toolpath. And what it does is it gives us an apples to apples comparison by looking at the event log, the Mastercam event logger, of exactly how long it takes to process that toolpath. So definitely check this out, and you can see different results based on different system types, processor speeds, different amounts of RAM, and the idea is to try and get everybody who participates to run the same test with the same or at least very similar inputs, and then look at the outputs and try to get a good idea about how different systems perform based on how they're configured. So I would definitely, if you're looking at a new system, I would run through here. I would look at each of the chips. Personally, when I build a computer system these days, this is what I do, and this is not going to be right for everybody. And you can certainly there is value to be had from building your own system at the component level and choosing different components based on price and putting everything together. The truth is, my life is so busy these days as I get older, as I have a family to deal with, that my days of sitting down tinkering with computers are pretty limited. I'm looking for best performance bang for the buck generally, and so what I end up doing is going to the Dell business outlet, the refurbished like scratch and dent performance section, and I tend to get a laptop that's about 40% off of list. For maintenance, better support optimization of white papers, post support. Yeah, I think you'll end up getting some of that stuff, and so here's the problem: is that optimization, white papers, post support, all of that stuff has been left to the resellers for a long time. So the truth is that you're not the customer for CNC software. CNC software's customers are the resellers, and they make their money by both selling the software and then selling support services, post services, training, all sorts of services that are geared around supporting manufacturing. I hope Sandvik does put some time and energy into making Mastercam more robust. The thing about Mastercam, I've been using it since 1997, and for all its faults, I've been able see, that's the thing, is you say disappointed all around, and to me, I've been able to make a very good living with it for over 20 years and been able to conquer problems in Mastercam that were completely insurmountable in other softwares. Problems where GibbsCam, HSM works, you pick a cam software, NX, CATIA, they basically fell flat. And, CATIA and NX and some of the other softwares that are more expensive are great as long as you're a large organization and you have money to invest in, the PLM technology and all the stuff that goes with it. I think if you knew historically what Mastercam's done, you would potentially be a lot more impressed. Perhaps not. But I've also find, the market is trash through and through. Depends on how much money you want to spend and what language you speak. Because to be honest, there is some great software coming out of Europe, and I won't get much more specific than that because, again, I make my living with Mastercam, and I don't want to steer anyone away from it necessarily, but if you speak French, there is a very attractive solution if you've got the money to spend to support it. If you ever look at a company out of Austria called WFL, they make arguably some of the best mill turn machines and some of the largest mill turn machines in the world. and they program with this other software package, and they program 100% of all of the actions on this mill turn machine in this other software package. It is pretty darn cool, but their US presence is very limited. Their advertising is almost nil. And yeah, we're kind of getting away from talking about Mastercam and what we came to talk about. So time to get back on topic. So what we're talking about is large data work pieces. How do we deal with them? First thing is to go in memory buffering, and bump up your memory buffering percentage. The other thing I like to do while I'm here is to suppress the plane's work offset warning. This is a new feature where the system will warn you if you change the work offset number, and doesn't have turn module, or does it have? I don't really know about too much about Mastercam for SolidWorks. That's not really a piece of software that I focus on, to be honest, because I focus on the standalone Mastercam side of the pond, just because there's so much that goes into driving mill software and turn software that I really focus on just using the standalone Mastercam itself. For dealing with large files, the other thing that can really affect us here, there's a couple of things. One is the tolerances. So if I go over here to tolerances, if you've got these really kind of cranked down to the defaults, chaining tolerance of 1/10, planar chaining tolerance of 2 thou. I'm working in inch units, by the way. So, metric, I would have different values on here. But this stuff is going to be fine for bringing in regular parts. If you're bringing in something the size of a ship or an airplane, something completely giant, you may have to go up here and set your tolerance to kind of, 1/10 of a millimeter, 1/1000th of an inch instead of, millionths, because the size of the object that you're bringing in is just so large, and it's hard to deal with it computationally when your tolerances are cranked way, way down. But the other thing that comes up is shading. This will really affect you when it comes to visually manipulating large models. So chord height. This is going to determine how faceted or how smooth your model is. So right now, my chord height tolerance is 1/1000th of an inch. And if I had a really big model to bring in, I would make it something like 10 or 20 thousandths. So kind of half a millimeter, quarter to a half a millimeter, I guess. In this case, 20 to 40 thousandths for my chord height. And if you do that, so I'll do that and set my chord height to be pretty loose like that. So I'll select OK. Now, you may not have noticed much of a change when I make that first change. Say something this size or bigger. This is a pretty big model, but generally I'm talking about stuff that's bigger. So for something this big, a 1/1000 chord height, so here's what it really comes down to. How long does it take to shade your model? If it takes like half a second, that's probably okay. It's probably acceptable. If it takes you 10 seconds to shade or unshade the model, that's when we really want to start adjusting some of this stuff, because chances are we have our display tolerances, things like chord height, cranked down much too tight for the amount of data we're trying to display. But the other thing that comes into play, the other thing we're going to talk about is how do we clean up these models? How do we reduce the data overhead, the extra weight that we're carrying around and probably don't even know that we're doing it? And so we'll talk about that in just a second. So the first thing I got to do to really see if that made much of an effect is unshade and reshade the model. So if I go to View and I go into the wireframe display, by the way, all of the models that I've got currently selected right now, or at least most of them, not all of them, are set to a thick line width. So what I'm going to do is I'm going to go over to my Quick Mask toolbar, select all solid entities with the, I'm going to click on the left side of the button, not the right side. You'll notice there's a 45-degree slash line through the buttons, and the left side, upper left, is all, and the lower left is only. So if I want to put myself in only selection mode, I can do that by pressing the lower half of the button, and then going and selecting individual models. So I've selected all solids. I'm going to right click and I'm going to go up to my line width command here, and I'm going to choose the thinnest weight of line, and then I'm going to do the same thing by just right clicking with nothing selected so I can change my current display attributes. So over in the operations manager over here, we've got a ton of different toolpaths, and a lot of them are selected. I'm going to select all the toolpaths over here, and I'm going to turn off only display selected toolpaths. There's this button right here, so I'll turn that off. Let's see if we can get it to there we go. So what I wanted to do basically was toggle through the toolpath display, select all operations, and turn everything on, and then turn everything back off. So that way I can make sure that basically nothing is currently selected or highlighted. So first thing I'm going to take a look at real quick here there we go. So I've got this folder open in Windows, and you can see here I've got two different versions of a similar file. So these are files that Jeff's been working on, and the first one here is 248 megabytes. Now, one of the things you'll see is that I have on my View tab here, I've got my details selected and I've got my preview pane. And when I do that, and I select these files, you can see that there's some extra information over in the right-hand side here below, below the little window of my face, actually. And you'll notice it says merged file name. There's actually some data above it that shows like the customer folder and some other stuffs, but it's actually hidden by this little window that's got my face on it, which is a good thing. I actually did that on purpose because I'm trying to keep this, kind of as neutral as possible. But one of the things you'll notice, I'm going to select this other guy over here, is just these paths that talk about the merged file name. So as you're working in Mastercam and you are dealing with lots of different files that have solid data, it's important to realize that if you are merging or moving or copying a solid, that those files, those solid models, contain a history. And that history is not just the operations that have been done to create, this solid object in 3D space, that it can include much more than just the physical representation of the object. So something that's really important is to be aware of that and know how to deal with how to strip out this extra information. So that's kind of what the main focus was supposed to be today. I mean, we kind of got sidetracked a little bit, but that happens. Sometimes it's nice to be able to just be able to ask questions for somebody who knows a few of the answers. I'll never claim to know it all, and there's certainly part of it for me is a lot of these training sessions, based on the descriptions that people give me of the work they're doing and the back and forth interaction, I end up learning just as much as I end up teaching, So what we're talking about, I've got this file right now open, and I'm going to just do this. I'm going to turn on all the levels. We're going to display all of the data that's in this file. And as you would expect, that takes a little while for us to perform that action, just turning on the levels so that we can display all the data in this file. I'm also going to select all, we'll just select all entities. I'll do Control A. And I'm going to set everything to be the narrowest line width. That way, if two entities are lying on top of each other, one is not, blocking the other. So we've got a ton of different models in here. And if I go and shade this, Control S is the command that I used on the keyboard to do that. I could always go up and click on, outline shaded up here. You can see that we have a lot of different models. Now, you'll notice that I just clicked and held on my center mouse wheel to roll those solids around in 3D space. When I did that, they actually moved fairly quickly. And they did that because if I go up to this little appearance tab and I click on shading options, I've got my chord height bumped up to 20 thousandths, about a half millimeter. Now, if I drop this down to 1,000th and I try to manipulate this around and I try to rotate it, especially since I'm broadcasting this on YouTube and, we've got other processes going to capture that video, encode it, send it to YouTube, do all that stuff with OBS Studio, the rotation that you would end up seeing would be really choppy. So dealing with large data sets, this is one of the first things that I change. The other thing you will notice is that if you are manipulating levels, if you are turning level visibility on and off, it will be much slower to do that if your models are shaded. The other thing we have to keep in mind when we're talking about with chord height parameters, shading and unshading of the model, is the display list. So what is the display list? When you look at the Mastercam database, you have data, items, lines, arcs, splines, solids, surface, geometric data that is located on levels. It is grouped, by that level number so that you can turn displays visibility of that data on and off. When the data is not displayed, when it is turned off, it's still there in memory, but when you perform a command in Mastercam, you're not acting upon anything that is invisible. So if it's not visible, you're not performing an action on that data, which is important because when you look at doing things like cleaning up a model, it's important to know if there are toolpaths attached to that model or not. And if there are toolpaths attached to it, you have to make a decision about, do I risk getting rid of that association, toolpath being associated with the model, and then clean up the model and then go back in and reassociate it by picking the model again? Or do I make a copy of that model somewhere else and manipulate the copy of the model for my purposes? So some of that depends on your purposes and on how much data you've got that you're working with, right? So there is displaying the data. There's a couple things we need to think about when we're talking in terms of cleaning up data. There is making sure you've got sufficient detail on the model for creating toolpaths. So you definitely want to save a copy of the original solid in the state where you're going to start working on it. So when we first bring in a model, let's look at one of our parts here. See if we have an op1 stock tabbed part. So here's this op1 model, and we've got a fixture and we've got a tombstone. So, and we've got stock. So let me turn this on. So this is kind of our very first setup for what we're cutting in op1. And this is a very smart decision, which is to take a copy of the part that we're working on and to modify that to include some tabs for holding it down. So you notice that they've added these tabs to the side of the part, and these are definitely most likely not on the finished model. But let's turn on the fixture and the tombstone. So this is basically, we're going to cut, we're going to rough this part out here, probably from 3 sides, right? It's on a horizontal. We're going to rough it out from the front. We're going to rough it out from this side, we're going to rough it out from that side. And this is arguably one of the more complex 3-axis style parts that I've seen in a while. It's just a large part. It's got a lot of features, a lot of holes. Yes, 3 sides. Yeah, the tabs are temporary, absolutely. Now, this is great as far as how the model is set up for roughing in this state. But the thing that we have to be aware of, or we should be aware of, is that if we're not cutting every feature into the model from this side, then the model itself has more weight to it. It has more data in the model than we really need. And so every extra feature, every extra hole, every extra pocket that's cut in there, every extra chamfer, all of that adds complexity, and all of that is going to be taken into account by the toolpath algorithm when you go to rough the part. So one of the things that I like to do is to, when I've got a roughing model like this, I like to de-feature it as much as possible. I like to simplify the model, which will decrease the amount of calculations that the algorithm will have to perform when we actually go to rough it. So for example, if we're not cutting in any of those holes at this stage because we're just roughing all the material off the back, we're going to flip it over, we're going to rough all the material off side 2, just to let the whole thing relax before we go to start doing some more advanced finishing on the part, then it would benefit us to remove some of these features. So, besides removing things like holes from the model, the other thing that we need to consider, or should consider, is, has the model been moved or copied? And are there any operations that were done to the model that we might need to manipulate later? Because what I'm considering doing, and what I typically do with all my models that I bring in, once I get the model like this set up, I really want to do 2 things. I want to create a manufacturing model, so that is basically a de-featured model that I'm going to use to that I'm going to use as the target for my toolpaths when I select my toolpath geometry, because it's going to speed up my toolpath calculations by using a more simple model. And the other thing that I want to do is, or I should say the other thing I want to consider, is the complexity of the entire assembly, because that assembly is going to be used in Verify or in machine simulation. So when we use, let me do this real quick. So, I picked a dowel pin and a pusher clamp just to demonstrate some of the complexity. There's nothing wrong with taking these models and bringing them in from the manufacturer and using them in your design and having a nice, accurate representation of all of the solids that are being used in your design. But the problem is the complexity of these features. So what ends up happening is we have a ton of different solid models. Press escape here. And when we go to run verify, we have to think about what's happening in the background. So what the software is doing, and I'll go ahead and do Alt-E to unshade or unhide all of those models. Let me do this real quick just to help give us a little depth. I'm just picking some different colors here to help some of these models kind of stand out against the darkness of the background, right? So I'll grab all of these clamps here. So there's nothing inherently wrong with really being detailed on your modeling. But the problem is it creates overhead. It creates data overhead that we have to consider both in terms of saving the model. So in other words, what's it doing to our database? How big is the database becoming because of that? And the other thing that we have to consider is how many facets, how many triangles are we creating when we go into simulation, when we go into verify or machine simulation. So when we go into verify, curved surfaces are the enemy. The problem with curves, the problem with smoothly sculpted surfaces is they're not flat. Now that may sound like a silly statement at first, but what you have to realize is that every model that gets used in verify first gets meshed. M-E-S-S-H. So what is a mesh? So what I'll do here is I'll go to a different level. We'll just create a new level here, 200, and we're going to call this temp mesh. And what I'm going to do, we're going to do a save sum operation. And I'll pick kind of this dowel pin, this clamp, and say this plate here. And we'll say end selection. And I'm going to save this as a stereolithography file. And I'll click on the options button and we'll look at the save as an STL little properties dialog box, and I'll choose ASCII and we'll output this in world coordinates. And we'll also give it a resolution, in this case 1/1000th of an inch, and we're in inch units, so that's going to be the current units. And I'll say OK. Save. And I'll turn off all levels. And now I'm going to go use File Merge. And I'll choose a stereolithography file. And under Options, I'm going to make sure it's set to import it as a mesh. And I'll say OK. So what I hope you can see is that we started with a relatively lightweight data object in the form of a cylindrical pin, and we then saved it as an STL mesh model, and an STL mesh is made up of only triangles. So each part of this STL, where it gets really detailed, when it's in shaded mode, it doesn't look that bad, right? But what you'll notice is that on each of these kind of curved teeth in this screw thread, there is a ton of data. Each area on this model that is curved now becomes represented by a big collection of triangles. And if I zoom out, I think what you can see is that around the areas in this plate where there are holes, we get a ton of extra data features. So if I zoom in on this hole and you look, you can see that, you know, on a big portion of this plate, we just have a flat triangle. But everywhere that a hole intersects, now we have all these little triangles that kind of fan out across that face because there was a curved surface that met there. So part of what we should consider is for verification to make a defeatured model, to make a model that is as simple as possible, but still accurately represents the outside skin of our dowel pins or our clamps. Because we still want to see if we're going to collide with that thing. You know, we definitely want to get the benefit of verification. Verification is checking our tool and our holder against our fixture, our stock, and our remaining part model to make sure that we're removing material where we want to, and we're not removing material where it would be a crash, right? So we're not hitting the holder into any of our tooling components. We're not hitting the shank or the neck of our end mill against the stock or against the part in some other area as we're finishing down. And so what we want to look at, and sorry it's taken me an hour and 15 minutes in the stream to get here, but I figured that that lead in with that information was pretty important. So what we're going to take a look at is how do we use the model prep tools to clear away the history of our solids and then manipulate our solids to remove features that aren't needed for verifying. So one of the things that I would typically do when I am setting up a model is basically have several levels that have the actual detailed tombstone, fixture plate, all those other features that I'm going to be using really modeled well, so that I know what I'm machining, what's getting loaded, all that stuff. My setup sheet looks good. Some things like those clamps, for instance, avoidance on the OptiRet. Will it still work if I convert them to mesh STL? So the question is, I use some things, like those clamps, for instance, as avoidance for the OptiRest. Will that still work if I convert them to mesh STL? Yes, it will still work. But what I'm talking about is actually having a detailed model with the full clamp in it. But for toolpathing and for verification, I just want a box. I want a rectangle that represents the overall size of that clamp, but does it with 12 triangles. Right? So a 6-sided cube or a 6-sided rectangle can be represented in its simplest form when we go in terms of a mesh with 12 triangles, right? So if I do this, let's do this, just so that we're really comparing apples to apples. Okay, so stock model test. And what I'm going to do, let's save this real quick. Exactly, simpler version that serves the same purpose. And the purpose is collision avoidance and collision detection when we go into verify, but lightweight. You want the model to be as lightweight as possible so that it does two things, so that it loads quickly and that it shades quickly. So we'll do a quick test real quick here. If I go back to my fixture, I'm going to do this. So one of the things I did real quick is I copied this clamp to another level so that I can create a stock model from it. Now, one of the things I wanted to point out, if you are merging models or if you are copying or moving models, that model retains the technical debt of being moved, merged, or copied. So internally, it's like a copy of a copy of a copy of a copy. And if we, for example, if we go and look at our solids, you'll sometimes see that it'll say copy of a copy, you know, of a copy, or it'll say imported or what have you. But it often won't show you that there's truly a lot of history that's gone into that model. If I come down to the group manager, by the way, this is, as far as I know, there used to be a couple other ways to get there, but now you have to go to the quick masks bar, and there's one button that says select all named group entities. So if I go down to select all advanced, and then I go down here and I click on Group Manager, one of the things that will happen as you merge part files or fixture components, whatever the purpose of the model is, as you merge models into Mastercam, in the background, Mastercam will create these groups for you. And things can get a little complicated as you start to further manipulate models that happen to be assigned to a group. So one of the things that I do right away when I come in, when I'm merging stuff in, is I just delete these groups. So again, I'm going to go down to Select All Advanced here in the Quick Mask toolbar. And I'll do this slow so you guys can kind of see it. And then from the Select All function, I'm going to go down and click on Group Manager up here at the fourth button down. And then in the Groups Manager right now, you'll see we've got 3 groups. So I'm going to select the first one and click Delete, deleting the group, yes. Second one, delete, deleting the group, yes. And in this case, Groups is a holdover. Groups is a geometry selection technique that is left over from like Mastercam V5, V6. Not X5 or X6, but V5 or V6. Back before, kind of levels was really a thing, and there were different geometry management tools. So, there was this option to group different components together. Now, you can still use groups if you want to. You can create a group, and then you can assign members to the group, and if you wanted to get into using it, you could, but I see less and less mention of it or people using it as a useful tool, because I think 2 things, levels and view sheets, have really kind of taken over that purpose, right? So deleting the groups, that's one of the things that you can do to kind of reduce that data overhead. The next thing, if I go to the Model Prep tab, so these tools are all about simplifying solids. There's some alignment tools, some layout stuff, but what we're really interested in over here, we have some direct editing tools. So we have push-pull, extends bosses or produces cuts based on the selected faces or features. You can use push-pull to create or remove fillets. Move and sometimes resize, rotate, or copy solid features or faces. Split solid faces, so divide a solid face into multiple faces based on the selected geometry, flow lines, or the UV of the face. Then we get into modify feature, modify fillet, remove faces, remove fillets. And then over here are some buttons that I use all the time. So remove history, add history, and then we have these 3 related functions. So we have simplify solid, optimize, and repair small faces. So a lot of these, like this one, repair small faces, analyzes solid bodies with no history, and reports back if it finds small entities such as spikes, sliver faces, edge pinches, and gashes. So it's going to try and look for these small errors and try to fix them. Optimize is one I really like. So this is an automated repair method. So automatically repairs imported solids, whole bodies, or individual faces by improving the accuracy of the edges and by identifying and optimizing blends. Toolpaths on the repaired solids will remain associativity to the faces. So you can actually optimize a model that already has toolpaths on it without losing associativity, which is a highly useful deal. So if you've already got a model that's got a bunch of toolpaths on it, you can actually run optimize on it without worrying about losing connectivity to that model whereas remove history is kind of the nuclear option. So remove history is the one we're going to look at first. Removes all operations from a solid's history tree, changing the selected solid into a brick solid. The other thing that it doesn't mention, but it does do, is it removes that merge, copy, and move data from the solid model. So I'll select remove history. Mastercam tells me, let's do background color red. Okay. So select the solids that are to have their history removed. I'll select those two solids and choose end selection. Now, one of the things that will do, I'm going to use my select button here. So now, for my solid body, it just says imported 1. You'll notice this is the 23rd instance of that model. So we've done at some point quite a bit of merging and copying that same entity, right? There's a bunch of different copies of this guy in this particular part file, which is not necessarily a bad thing if we go and remove the history after we've got them in place. So the one place where you don't want to remove history is if you intend to make modifications to an existing solid using the existing history tree. So that's generally never going to happen on an imported model. At most you might do the add history, but something like this where it's got some complex thread that winds through the model like this, good luck trying to add, I'll go ahead and hide it, but good luck trying to add history on a model that's got a complex thread form like this. And really, unless, I mean, this thing's going to have a set screw that sits down in here. So all we really care about is the exterior rectangular shape. In fact, little things like this. The car lane logo that is pocketed out on this side will increase the number of triangles that are going to be created when we go to mesh this model. So it is in our best interest to wind up with a simple rectangular block rather than this fully modeled pusher clamp when we go into verify. So if we go back to our levels here, we'll go back to our op1 fixture. What I would probably end up doing is keeping a model level in my Mastercam file that's got this full thing as a detailed model for when I do my drawings. But I would also have a verify level. So we're going to do this. We've got 1000 through 1004, and I'm going to create 1010, and we're going to call this the verify fixture assembly. And I am going to choose everything that's going to go into verify. So basically my op1 fixture model, my tombstone model. I am not going to choose my stock. My stock's already there, and it looks good, and it's got a hole in it. So if I shade that, it's got this lifting ring hole, but that's not so big a deal. I'm not going to worry about that. So tabbed part is my finished part. I'm not going to worry about that. Basically, this is all of the data that is going to be my fixture. Each piece of these, the tombstone, each clamp, the two pins and the plate, all of that data is going to be my fixture. So I'm just going to copy everything to my active level. I'm going to make sure that 1010 is my main level, and I'm going to turn everything else off. And then we're going to make this all the same color. Okay, and at this point, I'm also going to do on my model prep ribbon bar, I'm going to choose clear all, and I'm going to select everything here and hit end selection. And this is face color. So you'll notice there is set feature, clear feature, change face, clear all. So sometimes these models can have a feature color turned on and off. The other thing that we'll probably want to do when making a big change like this, I'm going to do remove history. So on all these models here, which is on my new level, new layer, I'll remove all that history. And the last thing that I'm going to do, because I'm doing a lot of manipulation here, File, Repair File. So this command is kind of the old RAM saver. I'm going to click Repair File. It says if possible the database will be compacted and the display list will be rebuilt. Do you also want to delete duplicate entities? I'll go ahead and say yes. And it's going to run. So it's taken a little while. Most likely it has been a while since Repair File was run on this particular Mastercam file. So it's finding quite a bit of data that it can clean up in the database. Wow, it's still going. So this is taking a while. Now this could also be because we're broadcasting at the moment. Sometimes, broadcasting over the internet takes up, memory from Mastercam and processes that it's trying to run. So that could be affecting this. But my guess is we're also going to see that it's reduced the file size by a fair amount. Oh, corrupt entities were not brought in. One corrupt entity. We say OK. Do we also want to combine parallel arcs to share the same view? You have to be careful with this. So depending on the plane that was used to create the arc, a lot of times Mastercam will find planes that are parallel to the top, front, left, right, back, bottom, kind of default standard planes. The problem is if we move them and they're associated to a toolpath, it will break that toolpath associativity. So if it's on a drilling path, we're going to lose the arcs or the, whatever yeah, the arcs that were assigned to that drill toolpath. And if it is part of a chain, we're going to lose the chain. And the worst is that sometimes you can just end up with a partial chain. So you'll regenerate the path. The path will look good because, hey, it's running where we told it to run. But the reality is it's chopped out part of the rest of our chain, and now we're going to have to go back and fix that stuff. So I am going to say yes. I just wanted to point that out for you guys. 661 arcs moved to a new view. So there was quite a bit of data there that was not, that could be simplified. So I'll say okay. Database is decreased by, only a fair amount, only a little amount. 2,720 bytes. So it's really only like 2 kilobytes, right? So we'll say yes, we want to save it. Some solids are in need of regeneration. You may not be able to retrieve this file again. Do you want to continue anyway? I'm going to say yes. And now it's going to ask me what I want to save it as. And I will do a 1,600 hours. Let's do that. So basically, I ran repair file to clean up my Mastercam file. It took a while to process. It tried to do as much cleanup as it could for compacting the database. It tried to rebuild the display list, but it also found a bunch of arcs that could be simplified by moving them to a different, basically construction plane in the database underneath, and doing that probably affected some of our toolpaths, both drilling and or contouring paths. Even something like a boundary that's used for like a 3D OptiRough. So there could be quite a bit that we now have to go and repair or fix in our model based on running repair file. So be aware of that if it's a tool you choose to run. I use it quite often because I want to know if there's simplification that can be done, and I want to do it up front to try and again keep my models and my Mastercam files as lightweight as possible. So if we go back to our toolpaths, what we'll see here, like this 500 ml, this is a 3D high-speed dynamic OptiRough, and my guess is the boundary got messed up. And then we've got a 250 ml here. It's another 3D dynamic OptiRough that got messed with. Here's a contour, so a 2D contour. Here's a 3D OptiRough, 2D high-speed dynamic mill. So some of these paths became dirty likely because the chain got broken, depending on what was actually selected. So if we go, for example, I'm going to turn on all levels. It'll take a second to display here. And I'm going to go back to my toolpaths. I'm going to select just this toolpath 67 here. And I'll do only display associative geometry. And when I do that, you can see, let me shade it real quick, that I've got this model, I've got this line, I've got this line, I've got this line, and I'm guessing that these arcs were part of the equation. So how do I tell if there was other stuff on that level? Well, I'm going to select that. I'm going to go and choose Analyze Entity, and it's on level 2003. So now I'm going to turn off Only Display Associative Geometry. I'm going to go back to my levels, find level 2003, and turn that off. And you can see here, yeah, that looks like if I was a betting man, we got a little overlap there. So might have some stuff that we have to repair there. Hard to say. But we can see, you know, for our toolpath wireframe level, that's where it was. And then this 2D high-speed face ends. Now, if I want to know what did this look like before I lost the geometry that was associated here, I'm going to save this. We'll just say yes. So we'll save it. Once it's done saving, I'll do a file new. And that clears out the Mastercam database. So then I'm starting with an empty Mastercam file. And then I'll do a file open. And we'll open up the version before I ran the repair file function. And this is part of why I gave it a new name when I was running repair file. Okay, so let's go. So we're bringing that in. Taking a while to come in. Here it comes. And some of this, some of the delay again is probably because I'm broadcasting this on YouTube, so keep that in mind a little bit. Okay, one corrupt entity was not brought in, but if I now go and I look at op2, and I think it was, what was it, 60, 57, 67, something like that. I want to say it was this one, face ends. So if I go to level 2003, and we go to our planes, to fixture 0, and we go look at this toolpath. Okay, so here's the toolpath for each of these files, and this geometry looks pretty clean. So hard to say if when we, if when we ran repair file, if it maybe untrimmed a little bit of that geometry. That usually shouldn't happen. So, but what we do know, if I select all arcs, select all arcs, I'm going to make those red. Each of these arcs is basically getting moved to a different view from the one it was created on. That's what happens when we do the there's a command here under wireframe for combine views. Combines all parallel views into a single view and moves arcs from the parallel views to a single view. Basically helps to clean up the internal construction planes used to build arcs. So in this case, let me just make sure. I'm going to do analyze entity, and it is 2003. Yeah, so these are all on 2003. So what I'll do then, but I do notice it's hard to say if there's overlapping geometry here. Ah, there it is. So it looks like that we've got some overlapping stuff here. And if I want to try and figure out what's overlapping, you notice I've got this guy right here. One of the things I can do is select these entities one at a time, and I can go to Analyze Entity, and I can see if there's a toolpath associated with it. So when I click here, this line is associated to both the stock model and Op74, which is a contour. If I select the other one here, and I do Analyze Entity, this one is associated to stock model 46 and Op67. So there's, you know, different geometry that's kind of lying over the top that can get in the way here. So what I'll do to toolpath wire, let's go 2057, and I'm going to say this is 57 or 67? 67. So I'm going to do levels 2067, and we're going to say up 67. Toolpath wire geo, and this is op 2. So what I'll now do is go on my toolpaths. I'll choose only display associative geometry, and I'm going to grab that and I'm going to move it, not copy it. I'm going to move it to my main level, my new main level, and I'll turn off these other levels here. And the other thing that I'll do, just to be sure, I'll grab it all and I'll do Analyze Entity, and I can just go through and see and make sure, kind of entity by entity, is this associated to more than Op67, which is the actual toolpath, and then Op46, which is my stock model. And I can basically just keep paging through these, and what you'll see is as I move kind of arc to arc, here's an arc that's on view number 2, which is the front plane. The arc beside it is on view number 27. So for some reason it got created on another plane that basically has that it could be simplified by doing it on on plane 2 instead of on a bunch of different planes. So by moving all this geometry for this particular path, let me go in and look at the machining regions. Okay, so this one's chained over here and goes that way. This one's chained over here, and I just wanted to make sure they were 2 complete chains, which they are. So what I'll do now I'm going to go to wireframe and choose combine views. And it should only be working on, oh, I guess it works on everything all at once. So it moved those. Now under my 2D high-speed dynamic mill, I'm going to go to machining regions. Oh, and you know what I didn't know before is where are the air regions? Okay, so those are these other guys down below. So that's good to know. Okay, so let's go to these machining regions, and I'll do rechain. I'll do that one and say okay. And let's see if we can preview it. Now that looks pretty good. And let it regenerate. Okay, so if we're dealing with that combined views thing, that is important to know. It's going to change your arc views, so you may have quite a bit of repair to do on the toolpaths. Move to the toolpath level, which I don't use in the future. No, that's a good call. I was just kind of pointing that out with how to deal with the combined views thing. I think your toolpath management strategies, I got no criticisms, man, no complaints at all. Everything looks really clean. Breaking toolpaths, so I did that to help separate things. No, it's a good strategy. What we're going to do though is look at, it was level 1010, and we had basically this fixture, and I call this a fixture assembly, right? Because it's a tombstone, it's a fixture plate, it's a bunch of pusher clamps, and then it even goes as far as the dowel pins that are used to locate the part. So we got these two dowel pins where the part sits and rests on top of, and then we locate it. So it's even a great fixture design. But what we want to look at is when I'm bringing this into Verify, how can I simplify it? How can I make it just as simple as possible? Because what we're really concerned with is the outside envelope. We're not going to be seeing if we can get our tool down inside any of these little holes. In fact, at some point, we're going to run out of y-axis travel on our tombstone and not be able to physically machine any further down. So we know that these holes are used to bolt the tombstone into our pallet, right? That's just the way it's designed. But what I'm doing now is I've copied these models to a separate file, completely separate, separate level, completely separate level. And now I'm going to use the model prep tools to clean these up. So if I go to my solids tab and use the select button here, you can see that here's my body. It's even got an extrude cut, which is there's something wrong with it. Looks like we got another dowel pin maybe that's located, something like that. Screws, something hard to say. What I'm going to do here, I'm going to delete that extrude cut, and we'll do a regen. And what I'll do here is under model prep, I'm going to do remove history. And I'll remove history on everything. I might have already done that earlier in the demo, but maybe not. So now if I do select, and I go selected, it should just say body. And let's look at this one model at a time. So I'm going to select the tombstone and I'm going to do Alt-E. And I've ran remove history. So the next thing I'm going to do is run optimize. And with optimize, I'm going to leave it on select body, and I'm going to turn off select face, and I'll select the entire model and click OK. and it tells me it's made about 1,100 changes. I'll say OK. And that tried to kind of clean it up as much as possible. Scared of the part falling. Nice. Okay. So what I'm going to do now is go to Modify Feature. And with Modify Feature, we can create a body, we can remove a feature, or we can remove and create. So I'm going to do Remove. And now what I'm going to do is go down to a feature like these little slots for bolting, and I'm going to try and double click on the wall. And by double clicking, it is going to try and select the entire feature. Now, I have to be a little careful, because depending on where I click, for example, I double clicked down here and it grabbed just the interior part of the slot. I've got the rest of the slots selected on all of these, which is okay. I'm going to go ahead and do Apply. And what you'll see is it removes completely those other slots. But here, I only had the lower part of the slot selected. So I'm going to double click on the wall and say OK, so I can get rid of that entire feature. I'm going to select that feature there. And basically, I'm going to go around and try removing a bunch of these feature holes, because I want this model in Verify to be as simple as possible. Now, one of the tricks I've got, if you look at this little prompt on the screen, it says, select one or more features to be modified or removed. Click to select a single face. I got to be real careful of doing that. If I just remove this single face here, I end up with a completely hollow shell, which I don't want. I want a full solid body. I just want to remove the features that don't provide any benefit to me. So I have to be real careful about clicking on a single face. What I want is a little feature like this little threaded hole part of the model. But it's also got click shift to select all holes with the same diameter, control shift click to select all similar faces, and control shift plus double click to select similar features. That is your friend. So I'm going to do control shift and I'm going to double click that little feature, and what you'll see is that it selected all 5. Maybe hard to see because the selection color right now is yellow and my model is orange, so that's a little hard. But if I unshade it, you'll notice it shows these 5 features in red there. So I'll do Apply, and that did a great job of clearing out those little holes on top. Now I've got a situation here, because I've got a lot of holes that kind of go through the model. And sure, I can do shift click and I can click the through holes that don't intersect everything, and that should remove them, right? So one of the things I can do is go Modify Feature, and actually before I go any further, I'm going to save the part file. So one thing I recommend is, as you're going through and you're doing these modifications, just make sure you save often, because that's going to make a significant difference. These solid modifications do not have a history. Let me repeat that. These solid modifications, when I do a remove a feature, there is no going back. There's no going backwards. So if it's something where there's a chance where if you screw it up, you're going to lose a lot of work, make a copy. Make and save a copy on a different level. Remove history on the copy. make it a new color, right? Make it different from the original in some way. Save your part file, and then do your modification work on the copied solid that is now a different color and a completely new solid because you've stripped away the history. And that way, if you happen to screw it up, you can always, create a new copy of the original solid and start over, because I've had it happen. I've lost, close to a day's worth of work because I just blew up this model and I couldn't get it back. And so, fortunately I had something that I could then copy in and do work on again. But, sometimes I'll spend half a day or a day just cleaning up a model, because the work that I have to do with planning the processing of going from operation to operation to operation, I can get a lot of benefit by making my fixture models, my in-process manufacturing part models. So not necessarily the final finished part, but the first stage, the second stage, the third stage, the fourth stage in manufacturing. I'm going to have different models for each of those stages, because I get an advantage computationally if I keep that model as simple as possible. So as we'll see in a few minutes, when I start looking at the part model, there are definitely some features that I can kind of quickly remove that are going to speed up my calculation time. So to select all holes with the same diameter, I can do Control plus click. So if I do Control and then click this, you notice I'm grabbing all of those, but I have to be careful, because if I remove the through holes, that's fine. These guys are fine right here. But if I remove these guys, you'll notice that there's this orphaned face. In other words, this is not a through hole. So there is a flat floor on the bottom, which is currently not selected. Meaning if I just remove all those, I'm going to be in a bad spot, because I'm going to have these flat floor faces that are inside my model, and they take up data, but they don't actually do anything. So I can depending on the operations that I perform, the order that I perform them, I can wind up with some really unintended results. So I'm going to hit escape, because I don't want to do that. I'm going to go back into modify feature, and I'm going to do Control Shift double click. So by Control Shift double clicking, I'm selecting every feature that is similar to the feature that I first selected. So I'll remove all of those. And hopefully that leaves me in a state where everything else is basically a through hole. So now for a through hole, I can just hold down Control and then click the cylinder and then select OK. So I'm going to apply that. I'm going to remove it. So now I've gotten to the point where I'm real simple on this model. Really, all I wanted was the outside. And of course, there are many ways to get to this stage, right? I could have created wireframe along the base and done an extrude so that I have the base here. And I could have created a rectangle and just extruded it up. And in about, a minute, I could have just built a new, more simplified tombstone. But I want to show you how to use the model prep tools to actually modify the solid rather than just relying on rebuilding something. So I can also try double clicking on the inside to select this as a feature. And because I removed all those holes and I selected one wall here that was on the inside, not on the top edge, it found that entire inner cavity as a feature. Sweet. because now I can just say OK. And boom, I have now reduced my fixture, my tombstone, to the simplest shape. I can now do Alt-E, and what I'm going to do here, I'm going to grab my fixture plate. Now we've got an interesting situation, because I've got, oh, they're not fully intersecting. That's good. I thought I had some intersecting holes to deal with, but I don't. So let's make this a different color just to kind of differentiate it. What's easy on your eyes? We use this kind of green here. All right, so I'm going to save the, first of all, I'm going to do Alt-E. I'm going to save this. I'll select it and do Alt-E to hide everything else. I'm going to do Modify Feature. We're set to remove, so I'll do Control-Shift, double-click. We'll do Apply. Control-Shift, double-click. Okay, so almost done here. So pretty quickly, I was able to take and remove all of those holes. For these pins, I do want to leave the pins in because I don't want to accidentally hit a pin. But I'm going to go to Modify Feature. And we're going to make these pins as simple as we can by removing the fillet and the chamfer off the back end. Now the other thing that we have to contend with is basically these pusher clamps. And they're rather complex because they're two pieces. And what we really want is the outside dimensions. So I'm going to hide everything else. Let's go into Modify Feature. Oh, can't remove that guy. So sometimes, depending on how this thing was constructed, you'll find features that can't be removed. And so what I do is I start to try and just remove the chamfers or fillets first. So for example, on something like this, I've got three corners meeting together. Try just removing the corner, right? You got this little mitered corner. Remove that first off the model because that is the last operation done to this section. Now I'm going to try removing just these little chamfer edges here. Okay, that worked. Now I'll try, go back and fit. Now I'll try removing just these little chamfer edges. So what you can see is I'm working from last operation done to first operation. So let's remove those final remaining chamfers here. So we'll remove those. I'm going to remove that as a feature. And at some point we also have to decide, is it worth rebuilding this, or is it better to just create something new? So what I can do here let me remove these little chamfers. And now we should have something that we can kind of lock onto. And instead of doing all the work to modify all 8 of these clamps, I am going to create a simple rectangle, translate it into position for all 8 of these, and then delete this double model here. So I'm going to go to my planes. See if any of these are sitting right. Nope. There we go. Equal. So we'll make this the place we're working. I am going to set my 2D, 3D switch to 2D and set my Z-depth down to the bottom here. And I'm going to create a rectangle. And we're going to go to Solids Extrude. And we're going to do by the length of an entity 625, and I'll say OK. So this guy, you notice it didn't take me very long to create once I had the edge intersections for where I wanted it to be. This rectangle is really all I need for verification. So let's do this. I'm going to delete out, oh, I don't want to do that. Let me undo, because what I want to do here is I want to copy this. So let's look at this in the top view. And I'm going to do a translation. We're going to do a copy, and I'm going to go from to points. So I'm going to go from that point to that point. So we're going to copy it 5.5, and I'm going to do that a total of 3 times. So we'll say OK. Now I'm going to grab the result. So I'm going to use my quick mask for result and my quick mask for group to grab all 4 of those entities. And I'm going to do another translation. And we'll go from point to point. Let's go again. Let's see. I want that point. Oh, let's reselect. Select the point to translate from. Oh, it's taking the whole vector. Okay, so I need a point. Let's go endpoint there. Okay. And we're going to get those guys. Oh, look at that. It gets the first one in position. So instead, what I'll do, I'm going to translate this guy, copy it, and because I'm in 2D mode, it's ignoring my z-depths. So you notice it just gives me this x and y, but the y is a little too high. So let's go 0.5 maybe. There it goes. that. 520. 515. There we go. So that gives me the first one. And now I'm going to grab my result. Select entities to translate. And now we do from that guy. So I'll do apply. We're going to grab all result again. And if we go to, there we go. So I'm going to do clear colors, and I know that my gray solids are the ones I want to keep. So I'm going to choose only color, and I can double click on this orange color, and that way I can make sure that I'm only grabbing the pusher clamp models and not the other gray guys that I created. So I'll select those and press delete on the keyboard. Now in my solids, I should have all my solids down here, and they are. They're all at the very bottom here. I'm going to go back into the extrude operation, and I'm going to choose both directions. So for each of these guys, I'm going to turn on both directions, and I'll show you why in a sec. So we're going to do both directions. So do that. We should have one more. Both directions. Okay, and then we're going to regen everything that's dirty. And the reason I did that, so do we still bog things down if they aren't being currently used? For instance, please, so we're to go back and simplify those. I always create a simplified fixture model to bring in to either verify or complete, but that's just personal preference. So the non-simplified models, if they're not being used, like the complex ones, I would definitely delete them out of my Mastercam file. The other thing you can do, save a version of it as like op10 or op1 or whatever, op1, op2, op3, so that you've got a backup copy where everything is fully detailed, and then create your working file without all the complexity. So it really depends on how much you're struggling, how much it is interfering with your workflow to have a very big data set that you're working with inside Mastercam. Because if you're working with a really big data set and it's bogging down your verify, or it's bogging down your toolpath creation, definitely for toolpath creation, this is so much easier. This is going to be 12, and a lot of times, if I'm doing an avoidance geometry, so the complex solid simplify, I simplify what I can, right? So if I'm doing an OptiRough operation and I'm doing an avoidance geometry, I'm not going to select this entire double set of two models that has all those faces. I'm not even going to select the entire rectangle. I'm going to select the top face. Because if I'm coming in from the front, right, if my tool's coming in there, all I care about is a surface on top that I'm not going to violate. Because I don't care if there's a surface on the side, it's that top face that's going to prevent my tool from plunging down any further on that clamp. So I'm going to take these clamps just like this, and in my OptiRough avoidance geometry, I'll select the top face of this pin. I'll select the top face of each of these solids, and maybe, the top face here or the edge face of this fixture plate, but that's kind of it. And I definitely do want to have separate solids for toolpathing and separate solids for verification. Because what I'm going to do is I'm going to combine all of these. So the reason I switched these solids here to be extruded both ways is so I could do a Boolean operation. So I'm going to go into solids. I'm going to do a Boolean. It says select a target body. That's my target body. And then select tool bodies. And I'm going to click on each one of these guys and say OK. And we're going to have this set to add. I'm also going to add 2 more tool bodies. I'm going to add that guy and that guy and say OK. And then over here I'll say OK. And what I've done is I've just turned that into one solid. Now it happens to be, if I select that solid, you notice I've got a body, but then I've got Boolean add underneath it. So I've still got a lot of what we call technical overhead. It's data overhead. It's data that is used to create the shape, but it's not just the exterior shape, it's all the interior stuff as well that we don't care about. So simply existing in an MC file is enough to slow it down. Yes. Because you got to think about things like storing. You've got a giant database. It's full of a lot of different entities. You've just added some simple geometry. Okay, you just added a rectangle, 4 pieces of wireframe. If you're searching for something, if you're turning a level on or turning a level off or doing something like that, there's a lot of operations where it's not just going to that one piece of data and manipulating that one piece of data in the database. It has to parse through the whole database. So things like turning stuff on and turning stuff off for the display list. A lot of these operations, it's like it has to iterate through the whole database before you get results. So I wouldn't say that's true with everything, but certainly as your files start to get really bloated, they start to get above, kind of 100 megabytes, that can definitely slow you down. Just, because there may be sometimes you need to do, all levels on or all levels off, or you're turning on all the geometry and you're shading it. And that takes time. The more quantity of entities you have and the more complex those entities are. So I've done this Boolean add, but I'm not done, because the last thing I want to do here, I'm going to go to this. Actually, I'm not going to do it on the fixture plate. The fixture plate's got some complexity to it, so before I do that, I'm going to go Alt-E here. I'm going to go to my model prep. I'm going to go to push-pull. I'm going to select that face, and I'm going to select my pull. And you'll notice when I do that, I get a slider bar that's got increments on it, but I also get the actual distance amount in a little data entry field that pops up there. Right now it says 2.13327. Once I go into the dragging command, so I'm actually dragging that face, it's actually responding. It will respond to keyboard inputs. So I'm going to type in 0.0005. Enter. So I extended this face out by 5/1000ths of an inch. And I did that so we would have a slight interference between the tombstone and the fixture plate. So now I can go into solids and I can go Boolean and I can select my target and my tool bodies, and I can add everything together. And the very last thing I'm going to do is go to model prep, and I'm going to remove the history. So I'll remove the history. I shouldn't say very last thing, because I'm also going to select all wireframe and delete all my wireframe. Now I should have one solid model that is my entire outside skin of my Op1 fixture. And I'll also go to optimize, and I'll grab the whole thing and I'll choose optimize. It's looking pretty good. For even more, I should say, for even less complexity, there's one more trick I can do here. So I'm going to do push-pull. Move this guy out of the way. I'm going to grab that face to push-pull. I'm going to click on the push-pull arrow, and then I'm going to click on the end of one of these clamps. It was a total of 15 thousandths of an inch, but what I'm trying to do is avoid any extra intersections. So I'm going to click that red arrow. I'm going to bring it to the end of these clamps, and I'll say OK. And just to be sure, I'll do a final remove history, and we can always try simplify solid. So I'll grab the solid. No potential simplifications were found. This fixture, let's do this. So here's how we do the apples to apples comparison. I'm going to save it. And under my stock model test here, you do mill toolpaths, stock model. And we're going to call this Op1 fixture test Boolean. Initial stock shape is going to be 1,000th, and we're going to grab a model. Triple click to select the body. Triple click, end selections, OK. And it generated pretty quick. And let's go, where's my display options? Where is this? There it is. Triangles, 568. So I created a stock model just as a test with 1,000th tolerance. So that was my tolerance. 1,000th was my initial stock shape. And it gave me 568 triangles. But it also gave me a fairly accurate model shape. If I go back in here and I make this initial stock shape a 10,000th tolerance, and it regens, now it's only 320 triangles. So if we grab, let's just grab, what do we have? Contour ramp. I'm going to grab this single toolpath. We're going to go to simulator options, and I'm going to set my stock to be my fixture test. And we're going to turn off fixtures, and I'm going to go into simulate. So I'm using this as my stock for simulation. It's not a real test. I'm not really going to actually use that to cut with. What I want to show you is tolerance. So the problem with a 10 thou initial stock shape tolerance on stock is that whatever that tolerance is, Mastercam actually goes and expands that model by that amount. So yes, you get less faceting, which is kind of the point, but you're not necessarily getting an accurate, fully accurate stock shape if you're manipulating that tolerance. But here's a 10 thou stock tolerance. And if I make this, let's make it 4/10. 1 thou is the limit, all right? So 1 thou, 0.001. It's going to regen. And it's 568 triangles. And if I go back into verify, contour ramp, we go back to verify. So that's a 1 thou stock tolerance. So you can see manipulating that tolerance whenever you have a round object, it is important. The tolerance value you use will affect the accuracy of the models you're bringing into verify. But also, a lot of times we use tolerance values that are restricting our performance. So for a stock tolerance for something like a roughing operation, I'd use 4 thou. 4 thou, 10 thou, 12 thou, something, something a little larger than just 1,000th if it's just a rough initial piece of stock. Use tolerance to your advantage. And one of the ways we can do that is by combining all these different separate models into a single Boolean model and simplifying everything down to the basic just outside shape to use for collision detection, because that's really why we're using it. Again, I wouldn't necessarily use that as the model for my toolpath, but I would for things like avoidance geometry, so in my level here, come on. Oh, I feel a crash coming on. Hey, you guys still with me on this live stream? My Mastercam's not responding, so might have to shut it down. Yeah, gotta kill Mastercam. Stop responding here. Well, surprised we went just about 2 hours, broadcasting and manipulating such a large data set before we had, some kind of issue with the system not responding. So I'm trying to restart Mastercam real quick here. Let's see how long this takes. There we go. Alright, just had to kill it. And we'll try bringing it back up here. So, I'm going to look or show just a couple little bits of defeaturing a part model, so we can look at some of the techniques that I use to do that. But really, that was a lot of what I wanted to kind of cover today was remove history, optimize, and simplify. So we talked about that a little bit, using those on solid models. The importance of removing history. So once you've got a model that you've copied, merged, moved, or repositioned, modified in some way, that you can get some performance benefits if you do a remove history. So whenever I'm bringing in fixture components from another file and I've merged them in, I always remove history. I always delete the geometry group. So just some things that you can do to kind of clean up your models. We'll wait till this thing opens up. So we got a question. I used 10 thou for the initial stock tolerance in the stock model, as well as the toolpath and shape tolerances. Do you think that's too much, and will it cause me problems? No, definitely not for initial stock tolerance. For toolpath and shape tolerances, no, that shouldn't be too bad. And there's a difference between stock model tolerance and toolpath tolerance. So we'll take a look at those just a little bit. No, in general, stock to so if we look up here at the kind of initial stock model, right now it's set to 1 thou. 10 thou tolerance would probably be great, and then depending on where you put your stock models, like if this is a stock model that's supposed to represent the finished part, those two past stock models are associated with, I was leaving 50 thou. Okay, that's good. So this looks like it's designed to represent the finished model. I totally get that. Down here, if we look at this guy, stock definition 1 thou. Yeah, this one really shouldn't have this shouldn't be using any of the toolpaths, I don't think. Let's see. Oh, this goes down here. Yeah, there's the stock, because we're on op 1, not op 2. So if I go this and all the rest of the stuff off, so let's do part. Okay. Oh, this is before we've done the. Oh, that's because this is the 1600 hours model, not the other model. And that's fine. So if I look at toolpath operations, real quick. Okay. So if we look at this high-speed dynamic OptiRough, and we look at the models. So we've got machining, and this is part of what I was talking about reducing the complexity of the models. So we've got this datum A, which is 12 entities, and 50 thou wall stock, 60 thou floor stock, and then we've got machining, 3,894 entities for doing a rough is quite a bit. That's quite a lot. So there's a lot of complexity that's left on this model, and for decreasing calculation time, there's quite a bit that we can do to clean this up and reduce the complexity of it. When we're talking about tolerance, though, if I go to the arc filter tolerance, what we've got here, total tolerance, is really a combination of our cut tolerance and our arc line tolerance. So the cut tolerance here is a bilateral tolerance. It basically means from the surfaces of the model itself, the actual individual slices that the toolpath algorithm is taking is now allowed to go plus or minus, in this case 2.5 thou, from the nominal geometry. And so we have this tolerance to allow the toolpath to create a simpler shape in order to reduce the geometric overhead that we have to deal with for calculating. And then so this cut tolerance is initially used to calculate the toolpath shape going around whatever we're telling it to cut. And then we have this line arc filter that is applied to the geometry. So the way that this works is, first the line filter flows down the path and sees within the tolerance that I'm given, are there any small line moves that can be combined or eliminated to give us a smoother path. And then this arc filter runs to then try to take pieces of the code and fit an arc in there. So we've also now got this new linking arc tolerance for arcs that are kind of the vertical arcs that are created when we're in linking mode. In other words, when we're going from the end of one cut to the start of the next cut. And we're either retracting up at rapid and moving over and moving down, or we're moving at feed rate and we're retracting up, we're smoothing, we're moving back down, and then we're starting the cut on the other side. So one of the things I really like to do is I always manipulate minimum and maximum arc radius. You cannot go lower than your total tolerance value. So that's the one thing you have to be a little careful of here. I think a 10 thou minimum arc radius is totally cool. 100-inch arc. I mean, think about that, 100-inch radius arc. Okay, that's a 200-inch diameter arc. If you traced out a 200-inch diameter arc and you looked at the shape of that, a segment of that arc is almost flat. So what I tend to do is use something like 2 inches, 4 inches, 6, 8, or 10 as my max arc diameter. Because anything larger than that, just make it a straight line, or make it a couple of straight lines. Because really, I don't want it to try and fit these large, giant arcs, unless for some reason I was, cutting a very shallow, smooth shape where I knew it was going to be a 30 or 40 or 50 inch arc radius, maybe in the G19 or G18 plane. And so I wanted it to try and create arcs that big. But otherwise I don't. I want to kind of cap the limit on my maximum arc radius. All right, so for defeaturing these models, which is the last thing I'm going to talk about today, we're going to try and wrap up here in a little bit here. Yeah, 2 hours and 45 minutes. We've been going for quite a while, so talked about a fair amount of stuff. But yeah, we're going to try and wrap up here pretty quick. All right, so got my tabbed part. I'm going to make a copy of it. So I've copied this model on another level, and this is going to be my model that I'm going to remove some of these holes from to help make it simpler. So the first thing I will do to help me differentiate it, let's make it a different color. I'm going to go to model prep and I'm going to remove the history. I'm going to save the Mastercam file because again I want to be able to kind of go back if I need to. So might not be a bad idea at this point to save it with a new file name, in fact, to make a new copy, something where again I've got a recording of how this model was. So this is a giant model. It's got a ton of features and I'm just roughing this out, which means that things like all these chamfers, probably all these holes, I don't need any of them at this stage. So I can start removing some of these features. So I'm going to go to modify feature. I'm going to go to remove, and I'm going to hold down Control plus Shift, and I'm going to double click. So basically I grabbed kind of these 8 different features there and kind of quickly removed them. There's a bunch more there that I can Control, Shift, and double click. Let's Control, Shift, double click those. Get all those. And so what you'll see is that pretty quickly, by using, a combination of Control, Shift, double click. Oh, found some that it wouldn't let me do. So sometimes you'll get features where it's trying to do too much at once. You're trying to remove some feature and it's just not having it. And if that's the case, sometimes you just need to kind of back up and just attack it one feature at a time. And don't be afraid to stop and save the model, right? Stop what you're doing with the remove feature and save the model just in case something happens that's catastrophic and that, as you're manipulating the geometry here, it just, breaks something, right? That's kind of what we want to avoid. All right, so we'll continue on over here. We're going to go modify feature. Let's remove that guy. And we'll Control Shift double click those. We'll do Control Shift, double click over here. Now, all I'm doing essentially is, defeaturing these internal holes. And in general, what I'm looking to do is simplify everything as much as possible. So for Op 1, I'm only attacking this from 3 sides, which means anything that's on the back side here is not needed at this stage in this model. Again, I've made a copy of this. This is the manufacturing model for Op 1. In other words, I'm not going to use it. I want to make sure that I'm not doing this on the only copy of the solid I have, right? I need to keep the original solid somewhere so that I can compare it back to it. But within, kind of, maybe a half hour or an hour of kind of going through and selecting these features and getting rid of them, I can make a significant improvement on the speed that it takes to toolpath these models. So here's a great example where I need to work in stages, right? So I've got these features that come in from the side which intersect this pocket. So if I try to just remove this pocket, I'm going to get a kernel interface error because I've got a feature that intersects it. Now that I've removed those intersecting holes, I can select the entire pocket and it'll get rid of it. I've got a similar thing going on over here. So what I'm going to do, and you'll see it, I've got some intersecting holes here. Intersecting holes up here. So I'm going to get rid of these guys. And I just need to be careful about not trying to do too much at once like that. So it tells me it couldn't do it. I say okay. I come back, I do one hole at a time. So I did that hole first. I'm going to come back and do this hole over here. Oh, that's the one. That's the one where it says, nope, I can't do that. I can't remove this hole right here. And it's probably because it intersects something. So hard to say exactly what it intersects. Maybe something from the back side. Could just be a modeling error. But here's a case where I can try double clicking everything on the inside there. And if I do that, you notice it's trying to remove this entire face. That's not going to work. So I'll hit escape. We'll go back into modify solid feature. And what we'll try is removing these two. So we'll try removing that. Nope, won't let me get it. Okay. Now what we can try is that guy. So I'll try removing just this little relief cut right here first, which it's able to do. We've got some more interesting geometry down here. If I grab that whole guy, will it get rid of it? It will. Okay, so that's one step down. We can look in here, and again, we're looking to see where is this intersecting geometry. No. Well, we can try just removing that. See if it'll let me do it. Oh, it did. Okay, there we go. So it could have been that this little scallop cut over here, for some reason, was like interfering with the piece on the back side. I mean, sometimes you just have to try a different approach for removing features in a different order to get it to work. So I'm going to double click on these to try and do these, or try and remove those as complete features. So it was those three little holes on top. Try and remove that feature. Alright, so grab that guy as a feature, remove it. Double click on that one, double click on that one and remove those. Now, when we've got these kind of funky pockets that are in the back here, right? This is all backside geometry. So here's the front side of my model. I'm working right now on the back side. And again, this will pay dividends for me if I am able to simplify the model enough that it reduces the overhead when I'm running OptiRough. So let's remove these guys here. Now, we've got some interesting geometry here because we've got like a pocket shape here, we got a pocket shape here and here, we got a pocket shape here, but they're all connected with these fillets. And so these fillets, if I just try to like remove this as a feature, if I just try to double click and remove that whole thing like this, that's probably going to fail. Yeah, impossible to heal, impossible to remove geometry. If I do this guy, which is just a little pocket that's not touching anything else, it'll do it. So I'm going to grab those two pockets and remove them. Now, how am I going to fix this? Do I need to fix it? Because one thing I could do is just grab kind of this outside shape and just extrude something up and do a Boolean and just kind of cover all this geometry. But where I can, I like to make this function work for me. So I'm in Modify Feature, Remove, and what I'm doing now is I'm going and removing these fillet corners. So I'm clicking on each of these fillets, but not too many at once. So for example, I don't want to remove this one yet. I want to remove all the other little ones. Then I can try to remove this guy when it's time. I'm going to remove these little internal fillets. Okay, so I'm going to go along the model and remove all of my little fillet geometry first, because this is the last operation that was done. So remember this, we have to think about removing. It's like peeling away the layers of an onion, and you're always peeling away the newest growth first. So now I've got a feature. So can I remove this feature? Let's try to remove that one. Nope. But can I remove this one? So in order to remove something like this, I've got something weird because I got a face out here, right? But if I try to do this, if I try the 3 inner surfaces plus this guy, it may be able to now treat that as a pocket. Nope. Okay, so then if that doesn't, could just be because of this. Could be that I still have too many little intersecting fillets. So we'll try getting rid of these first. You can also try doing something like getting rid of these little guys to try and see if that's treating it like a corner. Nope. Okay. So if we can't get it to remove these as features, then we have to see if we can push pull it. So now we exit the function, we save it. So it's just saving. All right, so I'm going to go to push pull. I'm going to click on that face. I'm going to drag it up till it finds the edge. Oh. So 0.3. It's giving me a little grief here in trying to select one of these corners. What I need to do is pick a point that's not part of the pocket. Pocket is 315 deep, yeah. So there's the 315. 315. Let's just get out of here real quick. Give me a point. Give me a point there. Okay, I'm in 3D. So, model prep. Push pull. I'm going to click on the arrow to drag it. Three, 1, 4, 9. There we go. So sometimes it can help if you have another simple piece of geometry to click onto. Okay, so I'm just using push-pull to take these faces. Now, I've brought this face up and this face up. What does that make this little guy here? Well, I'm hoping that makes it a feature. So now if I double-click that, because I've simplified everything around it, Mastercam's now able to treat that little shelf as just that piece. And now I can go to push-pull. I can grab this face, kind of find this midpoint here. Oh, come on. And you see it's grabbing a different location. There we go. So sometimes it can be a little finicky. You know, it can actually be a benefit if sometimes if you just put a little point entity on there to be able to grab that. So now we took that really complex section of the model and just removed that complexity by manipulating the model. Here's another one where this little racetrack feature goes around the whole model. It's got a lot of complexity to it, and if we're not cutting it in this roughing stage, well, let's take it out. So I'm going to do a push-pull, click on that face, so again, sometimes having that face that's easy to grab. I just took that whole entire channel and did a push-pull on it and raised that up. So now I can go and look at something like this, say modify feature. Oh, if I double click it, it's trying to grab that whole thing, which is not what I want. So I would probably do a push-pull on this face to bring it up and flat. Another great example where if we're trying to manipulate something, if I go to modify feature, I want to remove that feature first before I might need to manipulate, a fillet. Well, why would I want to manipulate this fillet? Well, this fillet is pretty small, right? So maybe I'm going to come in here with a 3-inch shell mill, so it's got an 1.5-inch radius. Well, it may be beneficial to move this out to like a 1.6 radius, so that I know that my 1.5-inch radius shell mill can turn a little fillet there. Turn a little arc. With simpler models, you'll also end up with a larger number of models. Does that ever cause the cons to outweigh the pros? So the total number of models and the complexity of the models is going to determine how this performs. So again, we talked about the difference between a manufacturing model and a complex model for display purposes. So I think at some point it becomes necessary to manage multiple files, with each file having a specific purpose. One file for design and layout and setup sheet generation, maybe because it's got the more complex models, but then another file where you're doing manufacturing, and I've had to have it where I've had kind of my op1 model, my op1 Mastercam file, my op2 Mastercam file, my op3 Mastercam file, and I don't like to do that, but sometimes it just becomes the nature of the beast when dealing with hundreds of megabytes of data and toolpaths. So some of it's really a judgment call, and to me it's always about how long is it taking me to shade my models? How fast are my toolpaths generating? And if that's what's bogging me down, then I start to look for solutions to keep the data lightweight, keep the Mastercam models lightweight, remove the complexity where I can. Don't use threads. That's a big one. Everybody wants to import every nut, bolt, and screw. A screw thread in a solid model takes an incredible amount of data. Okay, so model internal holes at either the minor diameter or the OD, depending on how you're doing your thread generation, and just, come up with a standard and follow that standard so that you know what each hole is and what each bolt is and what each thread is. And where possible, if you need that head, that bolt head for collision detection, model a simple cylinder and use that in your fixture versus having the entire bolt that's really just sticking down inside the fixture plate. Anything that's inside the model, you don't need. It's only the stuff it's only the skin on the outside of your fixtures that you care about for collision detection. That's it. So if you have a tombstone, everything on the outer faces of those tombstones, think about it like if you took a piece of saran wrap. If you shrink wrapped the object, that's what you want. That's the outside skin of the solid, skin of the part that is used for collision detection, and the rest of it is overhead that you're dragging along with you. So just keep that in mind when it comes to doing some of this stuff. So for roughing this out, if you are going to come and try to rough under here from the side, then you wouldn't want to do this where I raised it up and I did my push-pull. But maybe you do want to go in here and get rid of these little side pockets, maybe this little deep pocket in here. Just look at it from what features in the model am I cutting into the model right now? Right? So a lot of these little holes I would definitely take out and just make it as simple as possible. And the other thing is when you go to actually toolpath this, there's a huge difference, or can be a huge difference, between selecting the entire model and simply selecting the faces of the model that are visible in the view you're cutting in. So if this is the view I'm cutting in, I don't necessarily want to select every single face on the solid. What does this do for me in here? Okay, if my tool is coming from this view, right? This surface here, some of these other little surfaces, all of those are important. But anything that's deep on the back side here doesn't do me any good, and it just increases the calculation time. So be careful when you go into pick a toolpath and you're going to the model geometry here. So if I'm creating, a toolpath from this side, from the top side, I may only want to go in and select, just the faces I can see, right? So if I look at this from the top view, okay, I know I'm not going to jump into these little holes, right? So my tool is bigger than that, so I don't care. So really, I don't even need to worry about selecting these little guys here, because this top face, this top surface is going to get me there. It's not going to hurt anything if I do, so I might as well include, all these little guys here. But again, if I'm looking at this from this view, I need to be selecting the top edge surfaces or the top edge faces, and not necessarily the whole model. Because if I just do this, if I just go in and select everything I can see except for the holes, right? Let me select all these, select this guy, and I'd probably want something like a run-out surface so that I don't accidentally drop into some of these guys, right? But ignoring the holes for the moment, right? If I go out along here and I select all these faces, let's see what the difference is. So I'll just select all these faces from the top. Right, so grab all these faces. Depends on how deep we're going, of course. Some of these may be too deep for my tool to reach. But if I just grab all those and I say end selection, let me do this real quick. Unselect all entities. Now I go back in here. I'm not going to make you all sit through reselecting all these faces. Okay, but let me just select a few of them. So select a few faces. You might end up with 100 faces selected here, but that is going to calculate a lot faster with 100 faces and a boundary and some depth limits versus having 4,000 or 3,900 faces because we selected the whole model. So if I do unselect all entities, now I do select entities, and I do triple click, and I say, okay, 3017. There's 3017 faces on there. And that's only because I removed about a quarter of the faces by defeaturing the model, right? So there's quite a bit of performance to be gained by removing faces that aren't going to be part of a particular toolpath. So again, I would have an op1 model, I would have an op2 model, op3, op4, op5, and have each one of those be tailored to the work that was being done at that stage of the manufacturing process. Wow. All right, guys, we've been going for a little over 3 hours. 3 hours, 17 minutes. And I know there was, 20 minutes at the beginning of the live stream that was kind of getting stuff set up, getting the software working and all that. So I apologize for that. But let's see. You said you wanted to wrap up. Well, unless if you have to extrude something and bury a lot of features, any less overhead savings than removing the features. So the thing is, when you bury it, you have to go through a couple of stages, right? You have to do an extrude and create a body. Then you have to do the Boolean. You actually have to join them together. And then you have to run no history. So the end result is the same, right? Both techniques are equally valid as long as you remember to go through doing solids, doing Boolean add, and then after you're done doing the add, you have to follow that up with model prep, remove history, because it's the Boolean add actually creates more overhead, but once you remove the history, it just turns it back into a brick. The stock weight from 200 pounds to... Yeah. Hey, man. Happy to help, Jeff. He says, really appreciate your time. Fun fact, the first two rough ops brought the stock weight from 200 pounds to 23 pounds. So that's pretty impressive, man. That's about a 90% material removal in 2 operations, right? You're taking it from 200 pounds to like 23 pounds, and then probably shaving off another, 4 to 7 pounds by the time you get all the holes and all the little features cut out of there. So it's amazing, if we look at one of the cool things here, just before we wrap up, if I do analyze entity, and I select it, and we do properties, and I know the density of aluminum, you can calculate the mass of the part. So it does have the volume in this solid properties here. So again, if you know what the density of your material is, you can get a final number on the weight of the part. So, question. Is it possible to do some crafty surfacing that covers entire sections like a blanket instead of pushing and pulling so many pockets? Absolutely. But what you have to remember is not to select the entire solid when you're making the path. Only select the faces that you want to be visible. And what I typically call that, so for example, if I look at this in the top view, and I select a depth down here, so that's 13.42. And I go to my wireframe, rectangle, create surface. I will often do something like this that I like to call a run-out surface. Okay, so I would select that as kind of either my floor geometry. Actually, I don't want to select that as cut geometry, because if I select that as cut geometry, it's going to try to machine the whole thing. So if that's the case, I would really want to make this entire surface kind of only the extent of my stock. So wherever my stock was, I would want to keep this limited to the width and length of my stock. If I'm using it as drive geometry instead of avoidance geometry. But yeah, I usually call that a run-out surface. So I've got some surface that I'm using as a depth limit where I don't want the toolpath to go any deeper than that. And so here I would then go and select again where I showed selecting the individual top faces as opposed to selecting the entire model. There's nothing wrong with selecting the entire model, provided you have a powerful enough computer that it computes quickly. That's what it really comes down to, is how long are you spending waiting for toolpaths to generate? And if you're spending a lot of time waiting for those toolpaths to generate, then that's when I start to look at, okay, what am I including in the toolpath calculation that shouldn't be included? What can I eliminate? What can I simplify? What can I do to reduce the amount of computational overhead that is, preventing me from working quickly? Because that's what it really, comes down to, is how fast can I make good quality toolpaths. But yeah, no, this is Justin. That's a technique I use all the time. You just have to remember that when you're doing that, you're going to want to go in and kind of select individual faces, or in some cases, I'll even split the model up, right? Like I can take this, maybe drop this surface down another 200 or 300 thousandths, and do a split solid, right? So I can take this and do a split solid, and that way, that's a good demo, right? So if I do solids, trim to sheet surface or trim by plane, select bodies, that's the body, select a surface sheet, press enter, so I press enter, select the surface or sheet to trim to, and so you notice here I'm splitting that solid and it's getting rid of everything else below there. So in this case I'm trimming it all away. If I split the solid, it'll actually leave both pieces. But you have to remember, after you do something like splitting, you have to go back and remove history. So it's the removal of the history that really helps everything. So now I'm going to go back, model prep, remove history. I'm going to take this piece. I'm going to take this piece. I'm going to do end selection. And again, we're removing all that history. We're simplifying everything as much as possible, as much as mathematically possible. So now I am left with, kind of this chunk of solid, which is, if I analyze it, home, analyze entity, check solid, Let's go properties. Anyway, there's something on here I can use to kind of tell me solid mesh properties. Yeah, anyway. So splitting a solid is a great technique if you just are working on one little edge of it. Otherwise, creating and using run-out surfaces or like a patch surface, kind of laying it over a bunch of features. Perfectly great technique to use to just focus the machining not only in a certain area, but only down to a certain depth, coming from one direction. So yeah, that's also a great technique. So all right, guys, about 3.5 hours. We're going to go ahead and wrap up. So thanks everyone for joining. Let's see. Make sure we say hey to everybody else. Hello, everybody. Okay, cool. All right, guys. I'm going to go ahead and wrap this stream up. So thanks for joining me on this Sunday afternoon, coming into Sunday evening, and I hope you guys find it useful. I always love doing stuff like this, talking about Mastercam. Like I said, it's it's been a software that has made me a great living and helped me support my family for almost 25 years now. So that's weird to say because that's a long time. But yeah, thanks guys. Really appreciate it. Gonna go ahead and kill the stream here, and wish you guys a wonderful rest of the weekend. I don't know if you are fortunate enough to get Monday off. I am, which I greatly appreciate. So thank you guys, and this is recorded. Obviously, it's on my YouTube channel. So if there's something you want to review, something you missed, feel free to go back. If you've got questions about stuff I talked about during the broadcast, feel free to type in questions or messages of support, whatever, and on YouTube, and I'll try to answer them as I have time. So thanks guys. All right, I'll go ahead and shut it down, and wish you guys a great evening. Thanks guys. Bye bye.